Dear students, welcome to MSBTE online learning platform. We bring you the most relevant content in an exciting digital format. Today we will be studying a very interesting topic for Mathematics 2, Unit 1, that is differential calculus, which includes topic like function, where we will be studying some interesting facts about the function and we will be practicing some of the examples on it as well. Let us begin with few examples. Dear students, module of our subject is calculus, topic is functions. Concept of functions. Function described by an equation. Introduction of domain and range of a function. Find values of functions for specific values of variables. Learning outcomes are: understand the definition of function, solve simple problems based on function, before starting with the function, we are going to define the set. You know, set of collection of a distinct object is known as set. Now we are putting two different examples. Let A is equal to 1, 2, 3, 4 is one of the set. B is another set with the elements 2, 3, 4 and 5. We are interested to find the value of A union B. A union B is equal to 1, 2, 3, 4, 5. You know that. Now, there is a question. A union B is not equal to 1, 2, 2, 3, 3, 4, 4 and 5. Why? Because just I am giving one instruction to you and you have to follow it. You yourself just go and sit on the second bench also. Exactly, it is not possible for you to sit at two different places at the same time because this is the physical representation. Likewise, in the set, there is a physical representation of the elements. That's why in case of union, we can't place one element at two different places. That's why 2, 2, 3, 3, 4, 4, 5 are not possible. Now we want to demonstrate the concept of function by an example. You see, we have a torch, a disk with holes and a screen. As soon as we switch on the torch, light of the rays falls on the disk and ultimately we get as many as bright spots on the screen as many as holes are there in the disk. We can think over it. If you think, bright holes are created due to the effect of the light of the torch and we are getting as many as holes only, we are getting as many as bright spots on the screen as many as holes are there on the disk with the effect of the light. That's why light is the function for the creation of the spots on the screen. Therefore, in this case, light is a function from the set one to the set another. Here first set is disk with holes and the second set is the screen with bright spots. If holes in disk is denoted by X and bright spots as a Y, then the light of the torch is a function defined by the rule Y is equal to Fx. Now you see the another example. Suppose y is equal to fx is equal to x square plus 1 is one of the mathematical expression and we are substituting different value of x. When x is equal to 1, we are getting y is equal to 2. When x is equal to 2, y is 5. For x is equal to 3, y is 10. For x is equal to 4, y is 17. Here for every x, we are getting different value of y. By the formula y is equal to fx is equal to x square plus 1. Suppose 1, 2, 3, 4 are the element of the set A 2, 5, 10, 17 and 25 are the element of the set B. For every value of A, we are getting a different value of Y in B. For 1, we are getting 2. For 2, we are getting 5. For 3, we are getting 10. For 4, we are getting 17. That means for every x, we are getting one different value of y by the formula y is equal to fx is equal to x square plus 1. Hence, fx is a function from a set A to set B. Therefore, A and B are two non-empty sets such that every element of A is associated with one and only one element of B by a rule. Then such a rule is called function from the set A to set B and written as f A to B. Introduction of domain and range of a function. Now, for the concept of domain and range, I would like to give the same example. Torch is there, disk with hole is there, and a screen is there. Now there is a question, what is domain? What is the meaning of the domain? In fact, domain means field of action, where we work. That is known as domain. Here, with the light of the torch, we will work on the disk and we will get the spots on the screen. We are working on disk, getting spots on a screen. That's why the field of action is disk. Therefore, it is known as domain. Through light, we are getting result on a screen. That's why it is range, because the range itself means limitation. That is the limitation of the light and the hole that produces the spots on the screen. That's why a screen in this example is known as range and the disk is known as domain. Here I want to give another example to make the concept of domain, range and function clear through you yourself. See, you all are the students of diploma and all are putting all efforts to get job in best industry. Where are you? You are in diploma. What are you doing in diploma? You are putting all the best efforts for why? To get job in best industry. That means you are working at diploma to get a best job in industry. Therefore, diploma is your domain and the destination is industry. That means your limitation is industry. Therefore, industry is range and your efforts to get the job at diploma is the function. I hope and believe this is one of the appealing example for you to understand the concept of domain, range and function. Now you see the same example. Torch is there, disk with holes is there, a screen is there. We are focusing the torch, getting bright spots on the screen. What is bright spots? In fact, it is nothing but the image of holes. That's why element of the screen or the element of the range is known as image. These images are created due to the holes in the domain. That's why the elements of the domain is known as pre-image. Mathematically, we can say element of the domain is known as pre-image and the element of the range is known as image. Now, different types of function. First one is algebraic function. Any function having only algebraic expression is called algebraic function, such as fx is equal to y is equal to 2x square plus 1. Trigonometric function. Any variable with trigonometric ratio is called trigonometric function, such as y is equal to fx is equal to sin x plus cot x, y is equal to fx under root sin square x plus tan x. Logarithmic function. Any variable with log is known as logarithmic function, such as y is equal to log sin x, y is equal to log x plus log cot x. Exponential function. You see, any constant with variable index is called exponential function, such as e raised to x, a raised to x, 2 raised to x. But there is a misconception among the students normally they think e raised to x is the only example of exponential function. No, it is not like that. Any constant with variable index is known as exponential function. That's why a raised to x and 2 raised to x are also example of exponential function. Now the next one is explicit function. At this point of time, I want to ask one question from you. What is the meaning of the word explicit? The word meaning of the explicit is plain and clear. And what would be the plain and clear in mathematics? If one variable is expressed in terms of another variable, then it is known as plain and clear or the explicit function. That's why the formal definition of the explicit function is, if y is expressed in terms of x only, then such a function is called explicit function, such as y is equal to fx is equal to x square plus 2x plus 1, y is equal to sin x plus cos x. The next one is implicit function. You know, implicit is the antonyms of the word explicit. Explicit means plain and clear, saaf and suthra. Then implicit is mixed together, which is not plain and clear, is known as implicit. That's why if the variables can't be separated with each other, then it is known as implicit function, and is defined as if y is not expressed in terms of x only but mixed together is called implicit function, such as fxy x square plus 2x plus y square, fxy x square plus sin xy. It is not easy to express x in terms of y or y in terms of x in these examples because they are mixed together. That's why these are the example of implicit function. Parametric function, one of the most important function and interesting function. If x and y both are expressed in terms of third variable, to say alpha and beta, etc., then these are known as parametric function. But I want to make you understand by demonstrating one example. You see, x is directed towards a, in the bracket it is mentioned paternal cousin, chacha ka ladka. Again, x is directed towards b, it is mentioned maternal cousin and mama ka ladka. Now, I am posing one question, you have to answer only in Hindi because there is no definite concept of cousin in English. There is no definite relation. That's why you have to explain in Hindi only. Now, I am posing one question. What is the relation between A and B? The relation must be blood relation. And I am giving you 30 seconds. Time is up now. Okay. Bhai, no. There is no direct relation between A and B, but they are related through X. Since X is the brother of A and X is the brother of B, that's why A and B are supposed to be brother of each other. Such a relation is known as parametric relation. When it comes in the term of mathematics, such a function is known as parametric function. You see, x is equal to 80 square and y is equal to 280. X is defined in term of t, y is defined in term of t. That's why x and y are related through t. Therefore, these are the example of parametric function and t is the parameter. X is equal to sin alpha, y is equal to tan alpha. X and y are not related directly, but they are related through alpha. That's why alpha is the parameter, and these are the known as parametric function. In first example, x and y both are expressed in term of t, while the second example, they are expressed in term of alpha. Hence, for the first example, t is the parameter. For the second example, alpha is the parameter. Now, periodic function. If value of a function repeats after a regular interval of constant, then this is called periodic function. All the trigonometric functions are the example of periodic function. Even function. One sentence is there, India evented test series against Australia. You let me know the meaning of the sentence. Yes, India और ऑस्ट्रेलिया के बीच सीरीज बराबर हो गई. That means even means बराबर. I am concerned about the meaning of the word even. Likewise, if a function remains unchanged by changing x to minus x, then this is known as even function. Such as fx is equal to e raised to x plus e raised to minus x upon 2. Now here we are replacing x by minus x. You see, f minus x is equal to e raised to minus x plus e raised to minus x upon 2. We are getting the same thing, e raised to minus x plus e raised to x upon 2, which is equal to fx. That means by changing the sign of x, fx remain unchanged. Such a function is known as even function. Now you see the another example. fx is equal to x square plus cos x. Again we are substituting minus x in place of x. We are getting minus x whole square plus cos minus x. We know cos is an even function, that's why cos minus x is always equal to cos x. Here also f minus x is equal to fx. fx remains unchanged by changing the x by minus x. That's why these are the examples of even function. Odd function. You see one sentence is that nowadays I am passing through odd situations. That means इन दिनों मेरे हालात अच्छे नहीं हैं, मेरे हालात बराबर नहीं हैं. तो जब चीज़ें बराबर नहीं होती तो हम odd कहते हैं. If f minus x is equal to minus fx, then it is known as odd function. Such as fx is equal to x plus sin x. We are substituting minus x in place of x. We are getting f minus x is equal to minus x plus sin minus x, which is equal to f minus x is equal to minus x minus sin x. We are taking minus as a common, then it is minus x plus sin x, which is equal to minus fx. That means if f minus x is equal to minus fx, then such a function is known as odd function. You see another example, fx is equal to x cube plus x cos x. Again we are substituting minus x in place of x. We are getting minus x whole cube plus minus x into cos minus x. We know it is minus x cube minus x cos x. Again we are taking minus as a common, that is x cube plus x cos x, which is equal to fx. Here also f minus x is equal to minus fx. Therefore these are the examples of odd functions. For example, your question is, if fx is equal to x square plus 6x plus 10, then find the value of f plus 2 plus f minus 2. To find f plus 2 plus f minus 2, first of all we will find the value of f2. Since fx is equal to x square plus 6x plus 10, and we have to find the value of f2, that means we have to replace all the x by 2. Therefore 2 whole square plus 6 into 2 plus 10, which is equal to 4 plus 12 plus 10. The sum is 26. Similarly, f minus 2. Now we will replace all the x by minus 2. That is minus 2l square plus 6 into minus 2 plus 10, which is ultimately equal to 2. Therefore, f plus 2 plus f minus 2 is equal to 26 plus 2. We are substituting the value of f2, which is 26, and the value of f minus 2, that is 2. Therefore, the result is, now the answer is f2 plus f minus 2 is equal to 28. Now I hope and believe the concept of function is clear, and with this example you can solve the problems based on function. In fact, for the all practical purpose, to solve the problems based on function, you do nothing except replace variables by the given value of variables. What was the objectives? Objective was to clear the concept of function. I hope and believe the concept of function is clear to all of you. Now, functions described by an equation, just we have defined the function in term of fx is equal to y is equal to x square plus 1 and all that. These are the practical form of function to solve the equation. By substituting different values of the variables in any function, we are getting the value of the function. Now, fourth one is concept of domain and range of a function. If you recall your example where there is a torch, disk with holes, and a screen with bright spots, then you can notice when we are focusing the disk, we are getting bright spots on the screen. We are working on that disk through the light of the torch and getting bright spots. That's why The holes on the disk is the causative factor with the help of the light of the torch to create the spots on the screen. That's why disk is the domain where we are working with the help of the light and we are getting a result on a screen. That's why a screen is the range. And the torch is the causative factor to create bright spots through hole. That's why it is a function. A function is nothing but a relation between two non-empty sets. To solve the problem of a function, just you remove the variables for a given value of function. For all practical purpose, to solve the problem, this is more than enough to get the result of the function. Now we are fully competent to solve the problems of function, so worksheet is given below. Try to solve it. Solution of worksheet is provided for cross verification. Students, now you see the answer of your questions are here on the screen. First question is fx is equal to 3x square minus 5x plus 7. Then we have to show f minus 1 is equal to 3f1. First off, to find the value of f minus 1 is equal to 3f1, first of all we will put the function fx is equal to 3x square minus 5x plus 7. Then we will find the value of f1. We know x is replaced by 1 at all and every steps. By substituting f is equal to 1, we are getting f1 is equal to 5. Now, by the same way, we will find the value of f minus 1. That means we are substituting minus 1 at all place of x. That is 3 minus 1 whole square minus 5 into minus 1 plus 7, which is equal to 3 plus 5 plus 7 is equal to 15. We know 15 is equal to 3 into 5 and 5 is equal to f1. That's why f minus 1 is equal to 3f1. Come to the next question. If fx is equal to 16 raised to x plus log x with the base 4, then we have to find the value of f half. We know in case of function, we substitute the value at all the places of x. Then we are getting f1 is equal to 16 raised to half plus log of 4 raised to 1 upon 2. And we know 1 upon 2 is equal to 2 raised to minus 1. That's why it is 4 square whole to the power half plus log 4 2 raised to minus 1. And we know int x comes as a multiple. That's why it is equal to 4 plus minus 1 log 2 to the base 4. By using the shift of base formula, it is equal to 4 minus log 2 and log 4 is equal to 2 log 2. Log 2 and log 2 get cancelled. Now it is equal to 4 minus 1 upon 2, which is equal to 7 upon 2. That's why we got f half is equal to 7 upon 2. This is your answer. Third example, state whether fx is equal to e raised to x plus e raised to minus x upon 2 is odd or even function. We know if fx remain unchanged by changing x by minus x, then the function is known as even function. And f minus x is equal to minus fx, then it is known as odd function. Now we will check it. Since fx is equal to e raised to x plus e raised to minus x upon 2, we are substituting x by minus x, and we are getting e raised to minus x plus e raised to minus x upon 2, which is equal to e raised to minus x plus e raised to x upon 2. Therefore, we got f minus x is equal to e raised to x plus e raised to minus x upon 2, which is equal to fx. Hence, it is an even function. Now we are looking at the solution of the question number 4, which is fx is equal to x cube plus 4x plus sin x is an odd function. We know for the test of odd and even function, we used to substitute minus x in place of x. Therefore, here also we will substitute minus x in place of x. Therefore, f minus x is equal to minus x whole cube plus 4 into minus x plus sin minus x, which is equal to minus x cube minus 4x minus sin x. We are taking minus as a common. Therefore, it is minus x cube plus 4x plus sin x. From first, is it clear? Minus x cube plus 4x plus 7x is equal to fx. That's why it is minus fx. We got f minus x is equal to minus fx. Therefore, this is an odd function. Next, question number 5. Our question is f of x is equal to a raised to x. Then show that f minus x is equal to 1 upon fx. Question number 2, f m plus n is equal to f m into fn. Question number 1, f minus x is equal to 1 upon fx. fx is equal to a raised to x. Therefore, f minus x is equal to a raised to minus x. We know by indices a raised to minus x is equal to 1 upon ax, and a raised to x is equal to fx. Therefore, f minus x is equal to 1 upon fx. This question is proved now. Come to the next question. f m plus n is equal to a raised to m plus n, and a raised to m plus n is equal to a raised to m into a raised to n. We know it by the indices, and a raised to m is equal to f m. Now question number 6. Your question is, if ft is equal to 50 sine 100 pi t plus 0.04, then show that f 2 upon 100 plus t is equal to ft. Look at the answer. Since ft is equal to 50 sine 100 pi t plus 0.04, we are substituting 2 upon 100 plus t at each and every place of t. That's why we are getting f 2 upon 100 plus t is equal to 50 sine 100 pi. In place of t, we are substituting 2 upon 100 plus t. That's why this is equal to 50 sine 100 pi into 2 upon 100 plus t. This is the most important step for this question. If you sincerely multiply and follow the BODMAS, it is equal to 50 sine 2 pi plus 100t plus 0.04. Now, we are making a little change in bracket and writing like that, 50 sine 2 pi plus 100 pi t plus 0.4 into bracket. Now, this is in the form of 50 sine 2 pi plus theta, where theta is equal to 100 pi t plus 0.04, and we know sine 2 pi plus theta is equal to sine theta. That's why it is equal to 50 sine 100 pi t plus 0.04, which is equal to ft. Therefore, we will get f2 upon 100 plus t is equal to ft. Now it is proved. The next topic, module will remain same, that is calculus. We will be dealing with the limits. You have learned some important topics so far, and we hope you had good timing learning with us. Browse through our online library for more content on the MSBTE portal. Thank you. Stay connected. Happy learning.